Hi everybody. My name's George. I'm a front-end engineer at a legal tech startup in London called Orbital Witness. And today we're going to be talking about monorepos and how you can use NX to really get the most out of them. But before we dive into NX itself, I want to start by having a look at why you even need to worry about monorepos in the first place. So how did we get to the point where we need a tool like NX? So usually when a software company starts out, we'll start with something like this, where you've got a single app that you're building, and so you'll create a single repository. All the code goes in there, and different engineers from different teams can all contribute to it, and that's all great. But then as you kind of start to grow and scale the business, things start to change, and eventually you end up with maybe a second app, and you say, okay, that's fine, we'll start up a second repo, and we'll put all the code for our new app in there, and we'll run it alongside the first one. And yeah, this works to a point, but then eventually you say, well, actually, we use quite a lot of the same code in both of these apps. Let's go ahead and find a way to share code between them. And very often you'll create a third repo for your component library, and then publish those components to NPM, and then use them in your two applications. And yeah, this gets around the problem. But then eventually you kind of repeat this, and you end up with something like this, where you've got loads of different libraries in different repos, all publishing to NPM, perhaps consuming from each other. And so you get these kind of chains of dependencies, and then ultimately they get consumed by your applications. And obviously, the more applications you have, the more libraries you have, the bigger this kind of web of dependencies becomes. And this is problematic. And it's problematic for three main reasons, I think. The first is it simply takes longer now to get things to production, because you're not just making a change in the repository that hosts your application, like in the very first example, but you now have to make a change in your library repo, maybe then go and make that same update across a number of other libraries that depend on it before then pulling that into the application. And every time you do this, you're going to have to go through code reviews and CI pipelines and stuff like that. So it just becomes harder to get things done. The second thing is, although this was all started with the great idea of being able to share code between our applications, because we now have all of these steps, developers being lazy developers, don't want to have to go through that process of getting stuff reviewed in multiple places. And so they'll just start copy-pasting code between applications, and we're kind of back to the point where we're not actually sharing code, we're copying stuff around. And the third thing is, we've got all these different repos, and they're all doing things completely differently, different commands to run them, to test them. And so we kind of lose the mobility for developers. They're not easily able to move between these different projects and contribute to different projects without first having to understand, how do I run the code in this project? How do I run the tests in this project? And so these are kind of the issues with this sort of setup. The solution to all of this, the naive solution at least, is we just create one repo, and we put all of our apps and libraries into there in different directories, and we can import code from all different files in one place. We can do everything atomically, so we don't have this issue of following changes through multiple repositories, and we could call it a day there and say we're done. But really, this kind of co-location of code is a step towards a monorepo solution, but it's not an actual kind of monorepo in itself. And so we're not quite there yet, because we still have, I think, three kind of different problems that we now have to solve. The first thing is, with all of this code in one place, it's no longer feasible to kind of build, test, release everything all at once every time we make a change in this big monorepo. So we need a way of kind of controlling how we can do that effectively. The second thing is, although by putting everything together, we now have kind of the ability to have some consistency between all these projects. Just by having things in different directories within the same repo, we don't actually enforce any consistency. You still need to go into each of those different projects and figure out how you can run the tests or build it or whatever. And the third thing is, we're kind of opening ourselves up now to a bit of an issue where anyone can depend on any code really easily. And if you're a team that maintains a library and you don't know which other teams are using it, that can become quite problematic. Teams can start changing stuff all over the place, and quite easily things can become a big spaghetti mess that we don't really want. So we need a way to solve all of these problems in this new kind of monorepo setup. And the great news is that NX can help with all of this. So NX is an open source library. It describes itself as a next generation build system. And that's what it is first and foremost. You don't have to use it with monorepos, but it works extremely well with them. and it's designed to integrate with all of the tools that you're already using. So creating an NX workspace is super easy. You can just run an npx create NX workspace command and then just give your workspace a name, and that'll set up a bare bones workspace where you can put all of your projects. And then, yeah, like I say, within that workspace, you'll then have individual projects for all of your different units that would previously have been in separate repositories. And there are two main types of projects. So you've got apps, which are the actual deployable applications that you're going to be deploying, and these will combine together multiple libraries, which are the kind of other type of project. And a library in the NX sense is really just any smaller piece of functionality, components, or anything like that. So just a way of kind of splitting up your applications into smaller pieces. NX is built to be used with plugins, of which there are a number of official and community plugins. And these will provide you with two main things, so generators and executors. And we'll talk about what both of those are in a second. But as you can see, like, there are plugins for all kinds of different technologies, both within the JS ecosystem, but also you can use NX with other languages. So, for example, Go or .NET or various other things. So it's really extendable, and you can use it however however it makes the most sense for you to use it within your organization. So generators are a really important concept in NX, and they're used to automate tasks across your entire code base and kind of running large-scale changes. So that might be scaffolding new applications, it might be creating new component projects, or it might be updating configuration across every single project in your workspace. So if you want to make a change everywhere, you can use a generator to do that. And you can also, as well as using the generators, either the official or community ones from plugins, you can also write your own generators in your own local plugin using the NX Dev Kit, which is a library of tools for manipulating the file system, working with ASTs and stuff like that to actually manipulate code and generate code as you need to within your workspace. So we can create React apps using the React plugin, and there's a generator in there for creating apps. So I've already gone ahead and created an NX workspace. I've installed the NX CLI globally, and I've also installed the React plugin for NX into my workspace. I've already gone ahead and run the second command here as well, which is to create the first app. So we're just going to really quickly see how easy it is to create a second application with NX, and it's going to get us all set up super easily, super quickly. So if we come to our terminal, it's super easy. All we need to do is we just go NX and then G for generate, and then we just use the name of the plugin. So we're using the React plugin, and then the name of the generator. So in this case, we want to generate an app. So we just go app, and then the name of the app. We're just going to very creatively call it my app 2. And you'll see this starts up a little wizard, so we can choose which technologies you want to use within this app. I'm just going to use standard CSS. I'm not going to add React Router. I'm not going to add end-to-end tests. And for this, I'm going to use Vite as the bundler. And you'll see that goes ahead and it's going to create all of the files for our new project, and it's as easy as that. We don't need to worry about creating a new repo. We don't need to set up any CI pipelines. Everything's been done for us within our project. And so if we now look in our apps folder, as well as my app 1, we also now have my app 2. So my app 1 is using Webpack. It's a React app, and my app 2 is using Vite. So we've got two different technologies in these two applications. And the important thing with NX to realize is that every project has this project.json file within it. And this is where you can configure all of the specific configuration for that project. And we'll come back to some more details on that in a moment. So as well as generators, which we've just seen in action, plugins also provide you with executors. And executors are used to run tasks within your projects. So within your project, you'll define a number of targets, which are the things that you want to do with that project. So you might have a test target, a build target, a lint target, a serve target, and then executors define how to actually run that target. And they're configured in these project.json files. And a task is just an invocation of a target. So when you invoke a target and run the executor, that's known in NX as a task. And with NX, you can run tasks for multiple projects all at once, or just for a single project, depending on what exactly you want to do. But the important thing is you don't need to know what's happening under the hood. You don't need to know that my app 1 is using Webpack and my app 2 is using Vite. You just run the test target, and it'll either invoke Jest or Vite test for each of them. So we can really quickly have a look at how that works. So if we just go NX test my app1. That's going to invoke the test target and therefore the jest executor for that app, and it runs our tests and they all pass, and that's great, and that's just how we can run a single project target. What we can also do is if we go nx run many, and then we say target test, this is going to run the test target for every single project in our workspace that has got a test target defined. And so you can see that's gone ahead. It's run the test target for both my app1 and also my app2. But what's really useful here is we can see that my app2 ran and it took 1 second, and that's great. But my app1, it's actually saying that the existing outputs match the cache, and this is a really powerful feature of NX. So whenever you run a target with NX, the first thing it does is it takes a look at all of the source code of your project, any global configuration, dependency versions, CLI flags, and it's going to generate a hash of all of those. And what it's going to do is whenever it finishes running a task, alongside that hash, it's going to save all of the console output that was generated during running that task, and also the state of the file system. So if any files have been created, anything's been modified, and all that kind of thing. And the reason why this is so useful is that when NX first runs a task, if it finds a cache entry, which means you've already run this task on the exact same set of files with all the exact configuration before, it's not actually going to rerun that task, it's just going to replay from the cache what it sees there. So it'll replay all the console output and it'll move files to where they need to be as if the task had been rerun, but you don't actually have to run it. So as you can see, this is going to save a huge amount of time, especially if you're running a task across multiple different projects. Where this becomes super powerful, though, is with the idea of remote caching. So with this, we're not only going to cache these task outputs locally on our own machine, but we can write them to a remote cache, either with NX Cloud, which is the kind of natively supported feature for this. You can also use it with S3 or Azure Blob. And we're going to store that cache remotely, which means that any other developers who are working on your workspace, they can read from that remote cache. And if anyone else has ever run the same task on the same set of files in the same state before, they don't have to rerun that task. They can just use what's already being cached and don't have to wait for that task to run. This is super useful when you're using NX in CI as well, because it means if CI has run a task, a developer then no longer has to go and run that task on their own machine to get the output. They can just read from the remote cache and get all the results from there. So that's going to save you a huge amount of time when you've got all these projects in your monorepo and you don't want to have to run tasks for all of them. So really quickly, let's just create a library project in our workspace, because we're going to use this to demonstrate the next point. So we can create a library in the same way that we generated an app, NXG for generate, and then the name of the plugin, and we're just going to use the lib generator, and we'll just call it my component. We'll use jest for tests, and we don't want to have a bundler. And this is just going to go ahead, and in the libs folder, we've now got my component library, which is just a standard React component. Again, it has a project JSON file, which is going to contain targets. This one just has lint and test, because that's kind of what makes sense for just a single component. And it's important to note here that libraries can be buildable, so you can actually have to build them before they're used, and they can be publishable, which means they'll be published to NPM to use outside of your monorepo. But very often you don't actually need to publish them, because you're only going to consume them within your monorepo, because that's where all of your application code lives. So very often they're just used for code organization. And if you think about it, when we run targets, they're scoped per project, so it makes sense to really make your projects quite fine-grained so that you only run tests on the things you're actually changing. So let's take a look next at the NX project graph. And this is a super useful thing in NX that allows you to visualize the relationships between all of our projects. As you can imagine, in a large organization, you might have hundreds or even thousands of projects in your workspace. And so understanding how they all relate to each other can be quite difficult. And so the NX project graph is automatically generated by NX. It will analyze your source code, look at all of your imports and all your dependencies, and figure out what depends on what, and therefore changes to which changes to which projects can affect other projects. You can also define implicit dependencies for things that can't be automatically figured out. And a great example of this is when you have end-to-end tests. Your end-to-end tests should be rerun when your app changes, because the end-to-end tests kind of depend on the app, but it won't actually import the app, so NX can't figure that out. and in the project.json file as well, you can define those implicit dependencies. So if we come back to terminal now and we run nxgraph, what this is going to do, it's going to open up this UI. And if we hit show all projects, you can see we've got the 3 projects from our workspace, my app 1, my app 2, and my component. But right now, they're all totally isolated from each other. There's no connections between any of them because they are just completely separate projects. But what we can do now is if we stop that and we come back to one of our apps, and in here, let's just import my component that we created. And so you can see that's just been imported from the my component project within our workspace. And if we now rerun the nxgraph, what this is going to do is it's going to now show us that NX knows now that my component is a dependency of my app 2. And so this is going to be really useful when it's trying to figure out what things need to be rerun. So if we now make a change in my component, NX will know that that might have affected things in my app 2, so it should retest my app 2, rebuild my app 2, because it could have been changed by the changes in our component. So that's the project graph, and although our graph here is really simple, you can imagine this becomes quite complex when you've got loads and loads of projects in your workspace, and there's lots of ways in here that you can kind of drill down on exactly what you're looking for within the workspace. So we've looked at how we can run tasks, we've looked at the graph, and how kind of NX knows which things relate to each other. But eventually, running tasks across every project in your workspace using the run many command that we looked at earlier, it's just going to become unfeasible because there's going to be too many projects, it's going to take way too long. And so NX has this concept of the affected command, and this integrates with Git, and it means that NX will look at what's changed since either the last commit or comparing against another branch, and it will only run the tasks that are actually going to be affected by the changes you've made to your code. And so the best way to visualize this is if we just commit everything that we've done so far. And so if we now run NX affected target test, NX has gone ahead and it says it's run target test for 0 projects because since our last commit, which we just made, nothing's changed, so it knows it doesn't need to rerun the test for anything at all. But if we now come into the component that we created, and in here, let's just make a change and save that. So we've now updated my component, which is used, as we know, in my app 2. So now if we rerun the NX affected command, it's figured out that because we've changed my app 2, it needs to rerun the test for that. But it also knows that because my app 2 is a dependency, because my component is a dependency of my app 2, it needs to go and retest my app 2 as well because that could have breaking changes and the test might now be failing. So it's a really clever way of making sure that you only run the things you actually need to. It's useful locally, but it's even more useful when you're running tests in CI. And you don't want to rerun everything for every single project in the workspace, which could be absolutely huge. So the last thing I want to touch on is this enforce module boundaries ESLint rule that comes bundled in with NX. And this rule works with a concept called tags. And what we can do is we can set tags in our project.json files for each of our projects to tag them in whatever way is useful for us. And then this lint rule will restrict which projects are able to import from other projects based on the tags that we've set. These rules are applied all the way down the dependency tree, so if some far distant descendant has a tag, then that will actually feed into kind of this rule, and it'll warn us that we're importing something that we perhaps shouldn't be. So if we come back to our project, if we come into my component and we go into the project.json, you'll see that we have this tags array. And in here we can add tags. And really you can add tags related to anything you want. You might add tags based on teams, based on whether things are deprecated, whether things are experimental, all kinds of different stuff. So in this example, I'm just going to kind of create an idea that we have a team called Team1. And we've kind of, by doing this, we're saying like this component is owned by Team1. And then if we come into my app 2, and come into its project.json, we can also add tags, and we're in here going to say that this app is also owned by Team1. And Team1 have decided that they only want libraries that they own to be used by apps that they also own. And so what we can do is if we come into the ESLint.rc file, we'll see that we've already got this NX enforce module boundaries are all set up. And right now it's configured to have a source tag of anything can depend on libs with tags of anything. So right now any projects can depend on each other. We're going to go and modify this, and we're going to say we only want applications with a tag of team1. They can only depend on libraries that are also tagged with team1. And obviously this is a simple example, but you can see how this would kind of become more complex, and you can do some really clever things with this. And so now if we come back to the application and look at where we're importing this component, we can see this is fine. You know, this app is owned by team1, the component's owned by team1, that's absolutely fine, we're allowed to do that. But if we now come into the other app, which hasn't got the team1 tag, and we try to import the component, you'll see that straight away we get an error from ESLint, and it's complaining saying that, you know, the tags that are set up on these projects don't allow you to use this library within this application. And so this is a really powerful way of making sure that, you know, you can keep a bit of control over what can depend on what, and it doesn't become like a just crazy spaghetti mess of everything depending on each other. And so some of the reasons why you might want to do this, aside from like the team concept that we just talked about, you might want to use tags to ensure that if you've got different front-end frameworks within your monorepo, you don't want React apps to be importing Vue components, because that just doesn't make any sense. Or you might want to, like I briefly mentioned, if you've got projects that are marked as experimental, you might only want them to be able to be used in experimental applications and not applications that are actually running in production. Also, if you've got back-end projects in your workspace, you might not want to allow your front-end apps to use code that's been written just for back-end. And so you can do all of this through tags, and you can define whatever tags you like in whatever kind of formats you want to. So to come back to the kind of three issues we had earlier, I think we've solved all of them through these different features in NX. So the idea of keeping things fast, using the affected command to only run tasks on what's changed, and also the remote computation cache, where we don't have to rerun tasks on the same code twice. We're going to keep things fast. We're going to save as much time as possible. Enforcing consistency between projects so developers can move around. Well, we've got generators, which are always going to kind of generate code that's consistent in a consistent way, and we can make changes consistently across projects by writing our own custom generators to do that. And also with executors, you don't need to know the underlying technology in each project. As long as you know the targets that are available on it, so a test target, for example, you can just run NX test project name, and it's going to run. And you don't need to worry about learning the ins and outs of how to actually run things. And obviously, all of the executors are fully configurable within the project JSON as well, if you want to add extra configuration to them. And then the third issue that we had, this kind of separation of concerns idea, well, we can solve that through this ESLint rule by making sure that we kind of keep a bit of control over who can use which libraries in their applications, and you know, have a sensible way of sharing code rather than just allowing people to use whatever code they want and become kind of unfeasible. So this is just kind of some of the main features of NX. It's a super powerful library, and there's loads you can do with it. So I'd strongly recommend taking a look at it and seeing how it might be able to help you within your own organizations. And there are also, excuse me, there are also other libraries similar to NX that do similar things. And NX, yeah, it's not the only solution, it's just a possible one. So yeah, check those out as well. But the concepts are very similar between all of these different projects, and yeah, hopefully you'll find them very useful. Thanks very much.